Okay, hello everyone. I'll be talking about the first question of the exam. I will try to solve it step by step. Okay, so the problem: a bead of mass slides without friction on a friction wire in the shape of a cycloid with the equation, this equation here. Alright. So we want to find the Lagrangian of the problem. So, step number 1, determine the given. So, our given is the x and the y. So, our x is this and our y is this. But the equation for Lagrangian is this. So, L equals 1/2 mb squared, or simply 1/2 mb squared, or the kinetic energy, minus mgy, which is the t and the u. Okay, so let's set up the t first. So t is equals to 1/2 parentheses a theta minus sine theta parentheses squared plus the y1, so a parentheses plus 1 plus cosine theta parentheses squared, and then the u would be mg a1 plus cosine. So we have that. So now that we have this, we need to put the values here, combine them together. Hello? Alright. Sorry, my microphone died. Okay. L. So combine T and U, so 1/2 m. So let's combine all the like terms already. So that would be a squared. Oh yeah, we're gonna use binomial here, but let's combine everything using some algebraic manipulation. This one will be binomial, the binomial rule, and then add the like terms. You would end up like this. That squared cosine here plus that squared cosine here parentheses plus a squared that squared sine square theta. So if you combine that, that would be 1 ma squared 2 theta 1 cosine theta. But this is y. If you combine this and this, remember in trigo, cosine squared plus sine squared is equal to 1. So if you combine that and do a little bit of algebraic manipulation, I will arrive in this. Oh, sorry. This should be t. This is t. Alright, sorry. This should be t. And then let's combine L, t minus u. Let's get this. That would be 1/2 ma squared 2 there theta cosine here. Then let's add the mg. So negative mg a 1 plus cos. There you go. Now that we have this, we already have the L. This is the L. Now that we know the L, we can solve the Lagrangian. So the Lagrangian the formula is this. Alright, just give me 1 second. So, the Lagrange equation of motion is this, dt, partial derivative of L. This one would be for theta dot here, minus L theta here, then 0 here. Now that we have that, so let's get this first. Kunin muna natin itong mga theta dot, step, then get this, then get this. Okay? So, start muna tayo dito. Yan. So, theta, partial derivative, theta dot. So, our L is this. So, let's put the L here. Actually, this can be simplified pa pala. Okay, let's try to simplify this. Kaya pa palang ipa-simplify. So, we simplify this. This would become... Makakancel this one. So, MA2. Okay. Okay. So, basically, ang mangyayari na lang is MA2 dot 2, 1 cos theta minus, parenthesis minus MGA 1 plus cos theta here. So, let's do the partial derivative step by step. So, let's do this. So, this one will stay. But we'll treat this as a constant. This will be a constant. This will cancel out kasi walang theta dot. So, ang matitira is 2ma squared na constant to. Theta dot. Parenthesis cosine. There. There you go. Now that we have this, so we have this one here. So, this is for this. Now, next we'll go to this one. So that would be theta dot equals to MA2 dot 2 1 cosine equals MGA 1 plus cos here. So, this one will be treated as a constant, right? So, distribution property in algebra here and here, so that would be MA2 minus MA2 dot cosine minus MGA plus MGA cosine. So this is plus, okay. Alright, so let's this one will be cancelled, this one will be cancelled, and then we're gonna do partial derivative here kasi my sign, so that would be, this one would be constant, so negative MA2 dot squared derivative of cosine would be sine negative, so this one would become positive, then minus magiging plus rin to since constant MGA derivative is negative sine, but since it's a negative here, so magiging positive, so sine squared. There you go. So, this is our final answer. So, here, this one here. Now that we have this and this, we can add them together to get the derivative with respect to time. So, this would become dt, add both of them, this one and this one, in this equation. So that would be 2ma2 dot pi 1 cosine minus ma2 dot squared sine theta plus mga sine theta equals 0. Okay, let me have this. So let's get the derivative. Okay, let's get the derivative here. So this would be 2ma dot double theta, 2 dots here. So minus cosine plus 2ma squared theta minus sine theta dot theta equals ma squared dot theta squared sine theta mga sine equals 0. Hello? Okay, sorry about that. Okay, let's continue. 2ma theta dot out minus cosine plus 2ma here sine theta. I'm just doing some algebra here to simplify the terms and to derive it. That was mga sine theta 0. Okay. 2ma dot double dot 1 cosine dot plus, we're just simplifying the terms here, so I'm just demonstrating it to all of you here. Sine minus mga sine equals 0. So may masisimplify pa dito, and that would be this one, masisimplify pa to, cancel, and then what else? And then we're gonna use some trigonometric identity here. So 1 cos dot here plus here sine minus g 2a sine 0. So this would be our Lagrange equation of motion of the bead. So this is it. Okay. Okay. Today I'm gonna solve the second problem of our exam. So a particle of mass is attached to pore center with the force of magnitude k over r squared. Use polar coordinates to find the Hamiltonian. Okay, let's set up the equation first. So we're gonna use a polar coordinate. So let's find the kinetic energy. So to get the kinetic energy, okay, I'm just gonna, okay, there we go. Here, alright. The kinetic energy, alright, okay, would be P is equal to 1/2 m b squared. But since we want the polar coordinate, so 1/2 m b 1/2 b is equivalent to r dot 2 plus squared theta dot squared c. And then we need to find the potential energy. So we have the force. So in order to get, we are given the force, so we need to use this equation. But kinetic energy, potential energy equals to negative derivative F PR. Okay. Now that we have this, so we need to do the integration of this. So F is equal to K R squared, derivative here, dr. And K is a constant, so we need to bring out K. So 1 over R squared dr. Now, if we're gonna integrate this, so what will happen is that it will become K plus 1R. So the potential energy is K over R. Now, let's get the Lagrangian equation of the particle. So L is equal to 1/2 m r dot squared plus r squared plus theta dot squared parentheses plus k over r. Now that we have this, we already had our Lagrangian. Okay, let's move on to our next step. So we know the Hamiltonian expression of the particle is this. So this is the equation we're gonna use for the Hamiltonian. So H equal R dot P subscript R plus theta dot P and theta minus Lagrangian. So first step, we need to find this expression. So the expression for our polar coordinate of the particle momentum is P R L R dot. Meanwhile, P O P L P theta. So in order to get that, to get this first, let's get this first. So PR, partial derivative of Lagrangian R dot here. So partial derivative R dot 1/2 m. Oh, here. Sorry, I'm not being shown anymore. Okay. 1/2 m here. Okay, that's better. 1/2 m parentheses r dot squared plus r squared theta dot squared plus km. KR. Okay, now we have this. Now let's get the partial derivative. So this one will remain, this one will not remain kasi walang r dot, and this one will not remain. So this is 0, 0. So let's demonstrate this. 1/2 m to the r dot, it's 0 plus 0. So what will remain is PR m r dot. So in order to get the r dot, so PR r dot over m. Alright, now we have this. Next, let's get this one, the other one. So same procedure, but instead of r dot, we're gonna use this, the theta dot. So the expression for polar coordinate of the particle theta, so P theta dot theta, so theta dot 1/2 m r dot squared plus r squared plus kr. Alright. So, this one will cancel kasi walang theta. This one will have a derivative and this one will cancel. So, let's demonstrate this. So 0 plus 1 half m r squared to theta plus 0. Alright. Now we have this. So, simplify this term. So, that will be cancel. So, mr squared theta is equal to p subscript theta. So, we want this to stay. So, divide this to cancel out. So, mr squared theta. And that's the answer here. Now, we want to calculate the Hamiltonian of the particle. So, now that we have this, and this, and this, we can use this equation here. Wait, here, we can use this. The Hamiltonian here. We can use this. Okay. Okay. I'm gonna need another page, so another page. Here you go. I have another page. Yeah. So now I have another page here. So let's start inputting the values. So h r dot p r plus dot p pi equals L. So we have the R here. So the value a while ago is, I think, PRM. So PRM times PR here plus the value from this here. So that's P theta M R squared P dot minus the Lagrangian a while ago, which is M squared R2 P dot mr squared minus kr. Now, we're gonna add everything here using algebra manipulation, which will get p squared rm plus p2 pi mr squared minus p2 r to m p2 pi theta mr minus kr. Now we have this. So with algebra manipulation again here, using LCD to cancel some of the variables here, and adding the like terms, we'll come up with P2R to M plus 2 squared theta 2mr squared minus kr. Now that we have a Hamiltonian particle. Now, the equation of motion of particle in position. So, this is what we got. Now that we have the Hamiltonian equation. Okay. Okay guys, let's try to solve the third problem of part 2 of the exam. So which is compare H to the total energy. So we have the equation from the first equation, the answer from the first equation, which is H equals 1/2 m P squared R plus PO2R squared plus KR. Remember, remember a while ago, B is equal to K over R, and and P is equal to 1/2 MBR dot plus R times theta dot squared. So that is it. So we need to substitute this to the equation PR is equals to MR dot and P sub theta, which is MR squared theta dot. Okay, have that. So we need to substitute this. We need to substitute this here and substitute this here. Okay. Now, which is 1/2 M, which is MR dot squared plus MR 2R dot squared plus parentheses KR. Okay. So this will be M squared. This is be 4. This is will be I forgot something. Sorry. There you go. That squared. R squared plus KR plus R that's plus that M here. So if we simplify this, this will be, I did this a while ago, so 1/2 M R dot squared plus R squared theta dot squared and KR negative. Positive here. There you go. So TB plus B is equals to the total energy. So in the part 4 is the total energy conserved. So number 4 would be is the total energy is conserved. So H, or the Hamiltonian, represent the total energy. In short, Hamiltonian is conserved in time. H is conserved in time. That would be the answer for 3 and 4 and the whole problem. Okay, let's solve the third problem of the exam. A cubical gold nugget M hangs vertically by a light spring of force constant K inside a jar of wild honey. So the only thing that is not constant is T. So in order to get the velocity, we need to derive this equation, and to get the acceleration is you need to get the double derivative or the second derivative of this equation. All right, let's try to solve this. So this is the position. So let's find. So B equals dt. B equals the location. So this is y t over dt. So this one will be 0 kasi walang t. And this one will use chain rule to derive this. So that would be this one would be constant first. So that would be negative b e bt cosine km minus b2 t plus this. Then this is an equal sign. Okay, next, the next half, this would be, oh yeah, there's an a here. There you go, a minus bt, b, a, b, c. Then plus, then we'll get this one, so the derivative of this, and this one would be a constant, so the derivative of that would be negative sine kmb squared t plus this plus kmb minus b squared plus parenthesis here, then multiply by this one would be a constant, so a e negative bt. So if you simplify this using algebraic manipulation, so this would be d yt over dt. So make ilabas si a, so parenthesis b, negative b e bt negative cosine km here negative b squared t plus minus km negative b squared times e negative bt and then multiply by sine km negative b2 t. Yes. So this is, so basically this is our velocity here. Here's our velocity. to velocity natin. So, to get the acceleration, let's derive this again. Yan. D2 by T. So, i-derive na lang natin ito or twice derive ito in first equation. So, let's just derive this one last time. So, that would be dt equals negative b a e negative bt negative b cos km minus b squared t plus I minus km minus b squared times sine km minus b t plus this. So, if we derive this, this would become this. AE negative BT B squared cosine parenthesis KM minus B2 B squared T plus this. Yan. BT. There, BT. Yan. To B KM KM minus B squared sine KM this minus B squared plus this minus km minus b squared there parenthesis and then cosine parenthesis km b squared minus here and t plus this, and that would be our acceleration here. This is our acceleration. Now we want to find out if this thing is conserved or not. So have this. So we need to determine if it's conserved. So based on the equation, just since the force, so this letter C, if the net force, okay, oh yeah, so we need to determine it's conservative. So now that we know our A, we need F equals MA, so we just need to input this in MA. So therefore F is independent so the system is conserved. So there we have it. This is our third problem. We solve for the velocity, we solve for the acceleration, and we determine if the system is conservative or not. So F equals ma, and therefore F is independent, so the system is conserved. So there we have it.